Alright guys, welcome back to my YouTube channel. My name is Ayodele Kazum, your host on this channel. Thank you so much for watching all my videos, especially Alternative A, Chemistry Practical. Thank you so much for subscribing to the channel. Thank you for staying tuned to this channel. I appreciate it a lot. You are the one that is behind the success of this chemistry channel. Thank you very much. Today we'll be looking at Chemistry Practical, WAEC Chemistry Practical Alternative B. Okay, for those of you that watch Alternative A, I hope you enjoy your exam and I hope your A is sure. Let's quickly dive into what we have in store for us today. WAEC Chemistry Practical Alternative B. So I'll be bringing your way some likely questions on the chemistry calculations. We call it titrations. Okay, and for this part, I'm starting with an acid is HCl of 8.5 cm³ to be dissolved in 1000 cm³ of water. Base is NaOH of 6.0 gram per dm³. For teacher, for tutor, preparing for student for alternative B, there's a way you handle your calculated titer value without performing the practical. So we can use what is called dilution factor. Dilution factor for HCl from standard stock concentration is 11.6 mole per dm³, while 8.5 cm³ is to be dissolved in 1000 ml of water. Okay, develop 8.5 cm³ hydrochloric acid in 1000 ml of what? Of water. And we quickly calculate B. So let's quickly look at how to undo that. So the final volume is 1000, 11.6 multiplied by 8.5 equals to C2 multiplied by 1000. So when you do that correct substitution, you're going to have 0.0986 mole per dm³ of acid. All right, and for molar mass of NaOH, you're going to have 23 plus 16 plus 1 will give you 40 gram per mole, and concentration of mole per dm³, concentration mole per dm³, gram per dm³ over molar mass, that's 6 divided by 40 will give you 0.15 mole per dm³ of the base. Okay, let's look at a balanced chemical reaction. You have hydrochloric acid plus sodium hydroxide to give us sodium chloride plus water. Okay, it's going to be 1:1. When you look at it, you have 1:1 in that order. This one is 1. That's 1 mole of acid and 1 mole of your base. We are working with CD, VD, and ND. That's number of your acid and number of base. Here, our A is going to be, our acid is going to be D, it's no longer A, while our base is going to be E, is no longer B. Take note, because in alternative B is actually your acid stands for D and your base stands for E. If alternative A, acid is A, base is B, and salt is C. But when you come up alternative B, your acid is D and your base is E, while your salt will be F. So let's continue our calculation. So we substitute respectively. Our C is 0.098 as we obtained from the value calculated. VD, that's what we are looking for. That's the volume of the acid used. Our C is 0.150 and VE 25. That's the volume of the pipette used. In my own school, 25. In your own school, it might be 20. And from here, the ratio of the acid is 1. That's why we can see 1 here. While the ratio of the base is also 1. That's why we have 1 here. So when we substitute correctly this value, we are going to have 0.098 of the acid, the volume of the acid, the ratio 1:1. So when we do that, we're going to have our VD, okay, the expected or the calculated volume of the acid to be what? To be 38.00 cm³. So this is what I'm going to be using in this particular experiment to solve a lot of problems, likely questions that you might try your answer on. And by God's grace, I believe you will not be stranded on the day of chemistry practical. Good luck. Let's dive into question number 1. Now, titration. The question says, D is a solution of HCl containing 5.0 gram per dm³. E is a solution of what? KOH. Now, put D into the bread. Put D into the bread and titrate against it 20 cm³ or 25 cm³. Okay, for the purpose of the practical, I've been making use of my volume of pipette to be what? To be 2500 cm³. Indicator here is material. You can as well use phenolphthalein depending on how the question come. Okay, that's not a problem at all. Repeat the experiment, repeat titration to obtain constant titer, tabulate your breath reading, and calculate the average volume of the acid. The acid there is D. Remember, I told you use. And you have been given some parameters. Hydrogen is equal to 1, oxygen 16, chlorine at 5.5, and sodium 23. As the case may be, you might need them and you might not need them. But that's the given value in this particular question. So let's move on to our table of value. Our table of value is here. Okay, look at our table of value. It look like my rough here is what? 0.0. I have 38.20 cm³, and final answer is 38.20 as my rough. My first is 38.00, my second is 38.10, and my third is 38.00. So I'm going to be using first, okay, and I'm going to be using my third value, okay, my third value. So 38 plus 38, of course, give us 76 divided by 2. My final volume becomes what? Becomes 38.00 cm. You can refer to this video if you want to know how to arrange your table excellently. Refer to this video I'm putting up there. I made a video on how to arrange your table. If WAEC want to mark, it will give you 4 marks here. It will also give you 4 marks here. Okay, you give you 1 mark. It will give you 1 mark for the final answer. So in other words, you are looking at 10 marks. 10 marks on the table. Did you get that there? Okay, let's move to the question how to solve. Question number 1, we have to, from the result and the information provided above, calculate the concentration of D in mole per dm³, concentration of E in mole per dm³, concentration of E in gram per dm³. Let's dive into the solution. Question of D in mole per dm³. Remember, we were given our D is hydrochloric acid, okay, which is 1 plus 35.5, which gives us 36.5 molar mass. Take note, students, when anytime you are asked to calculate molar mass, or you need molar mass to calculate to solve a particular problem, you need to remember your unit in gram per mole, which is molar mass. Please don't forget. We take note of it as an examiner. So let's use that formula. Conc mole per dm³, because of conc gram per dm³ by molar mass. The mole per dm³ given in the question is the gram per dm³ given in the question is 5. Divided by 36.5, we have 0.13 mole per dm³. Remember also, anytime you are calculating mole per dm³, make sure it's always 3 significant figure. 3 significant figure is very, 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 very important. We take note of it as an examiner in chemistry. We don't joke with it. Please take note of all these simple things there. That's where your marks are. All right, let's look at conc of B mole per dm³. This one you can use CD VD equals to ND, and CEV equals to what? NE. Remember the value. You can see the value. Then what do? Substitute the value respectively. You can see the value of the acid, the volume of the acid. You are looking for the concentration of base, and what it makes that one subject formula. You have your answer, okay, to be 0.20 mole per dm³ of the base, which is E. Now you need to calculate your concentration in gram per dm³. What's your base? Your base is sodium hydroxide. That's 23 plus 16 plus 1. That's give you 40.0 gram per mole. Remember, your molar mass must be in gram per mole. All right. When you substitute that in this particular equation, you're going to when you substitute that in this particular formula, you're going to have 0.20 mole per dm³ multiplied by 40, because you're looking for your gram per what? Gram per mole. So your answer, final answer, will be 8.3 gram per dm³. Did you get that before me, students? So let's go to question number 2. Okay. All right. Question number 2 says you are provided with 2 solutions, D and E. D is a solution of hydrochloric acid, while E is a solution of sodium hydroxide containing 1.0 gram per 250 of the solution. Of course, you're going to go through the same routine, put into the breath and titrate against 20 or 25% of the using material as an indicator. Then repeat the experiment titration to get your consistent titer value. Then you form your table. We're using the same table. I've already explained table in the example number 1, so that I will not waste more time on it. But make sure you get your 10/10. Table is very, very cheap, please. Table should be a bonus to all the questions, all the students that have been practicing titration. So let's quickly dive into how to solve the basic problem inside this question. From your result and information provided above, calculate the concentration of E mole per DMQ, the concentration of D mole per DMQ, and the concentration of D in gram per DMQ. Look at the other question that I calculated. So let's look at it. We're going to be converting first. You convert 1.0 gram. Remember, why are we converting? Because 1.0 gram is not in DMQ, it's in CMQ, which is 250, right? It's a little bit different from question number 1. Question number 1, you are giving 5.0 and you are using it in gram per DMQ. But here you are giving 1.0 in 250. So you are going to convert it. So when you do that, okay, you are going to have 4.0 gram. This is now gram per DMQ. All right. Then you can now use your formula by first of all calculating your molar mass of the base. Okay, and use your formula 4 divided by 40 give you 0.1 of what? Of your base. Are you following? Of your E. So let's calculate the concentration of D mole per DMQ by using this formula. Then we substitute respectively. I like sorting out my parameters first. I'm looking for CD. Of course, I have my VD, CE, and all of that. Then the next thing, I substitute respectively. Then after that, I make my CD sort of formula. Then I have my final answer to be 0.658 mole per DMQ. Remember, anytime you are working with mole per DMQ, you must put 3 significant figure. Did you get that? Okay, we are moving gradually. 3. Concentration of D in gram per DMQ. Calculating your molar mass of HCl is 1 plus 35.5 give it at 6.5. Conc mole per DMQ equals to gram per DMQ over molar mass. Then what do? You cross multiply. Then you have your 2.4 gram per DMQ as a final answer. Hope you are enjoying it. Question number 3, we are moving very fast. D is 0.100 mole per DMQ of an acid. This acid is not given. You don't know whether it's HCl or not. And E is a solution of NaOH, 2.8 gram per 500. So you put D into the burette and titrate it against 20 or 25 depending on the pipette you use in your school. You can use methiorin as an indicator. Repeat the titration to obtain titer value. Then you have your table as this. Then we have your final VD, volume of the acid at 38.00. So let's look at what the question has for us. The first question says, calculate the number of mole of acid in the average titer. But to calculate the number of the base, of course, in the volume pipette, and the mole ratio of the acid to base. It's a little different. Okay, let's see the kind of formula or the kind of approach we can apply to this kind of question. You remember, we don't know the acid. They just say an acid. They didn't tell us whether it's HCl or it's not HCl. So the number of mole that we can use is conc in a mole per DMQ multiplied by the volume divided by 1000. And our conc mole per DMQ is 0.1 multiplied by our volume of acid, which is 38.00, then divided by 1000 give us 0.0038 moles. Remember, moles of what? Of the acid, which is D. Let's go to the second one. Remember, we are giving 22.8. Anytime it's not in gram per DMQ, you must convert it to gram per DMQ. That's the whole essence of this expression. So 2.8 to 500 x to 1000. Then we have 5.6 gram per DMQ. What do? Calculate your molar mass. Then you convert it to mole per DMQ. It gives us 0.140 mole per DMQ of E. Now let's convert that to moles. So you have 0.140 multiplied by what? Multiplied by 25 divided by 1000. It gives you 0.0035 moles of B. Remember, E is what? E is our base. All right. So let's look at the mole ratio of our acid, which is D, and our base, which is what? E. So mole ratio of acid is 0.0038. Base is 0.0035. The next thing is to divide by the smallest. Out of these two parameters, when it's smallest, 0.0035 is smallest. So divide both sides by that. What do you have? You have 1:1. Now, 1:1 shows us that any acid that you are reacting with the base, which is sodium hydroxide, must give you 1:1. For instance, let's say HCl plus NaOH will give us what? NaCl plus H2O. Okay. Now this is 1:1. This is what? 1:1. Okay. It's not only HCl that can work in that order, because they can ask to suggest an acid that can go if the kind of question come out. Let's check HNO3 plus NaOH. Of course, this one will give us what? NaNO3 plus H2O. So when we look at, we also have 1:1. But if you use H2SO4 plus what? Plus NaOH to produce what? Na2SO4 plus H2O, it won't work. Okay, it will not work. The balance equation is giving us 1:2. 1:2. So this acid cannot work for this. So the two acids that probably work for the mole ratio, if you has to suggest acid, is a mineral acid of what? Of HCl or HNO3, because they gave you 1:1. Thank you. And the basicity is also what? 1. The basicity of this one is 1. That's monobasic. Let's quickly go to question number 4. D is a solution of hydrochloric acid containing 2.8 gram per dmq. This is a solution of an impure sodium hydroxide containing 7.3 gram per dmq. Put D into the burette, then the same process. Then you have your titration table. Then we have a final volume of acid to be 3.8 cm3. So let's look at the likely questions. Say from the result and the information provided above, calculate the concentration of D in mole per dmq, concentration of E in mole per dmq, percentage purity of sodium hydroxide in the base. All right, look at the twist. This twist came out in WAEC. They asked us to calculate the percentage purity. Anything can still happen again, and it might not. But no knowledge is waste. All right, question of D in mole per dmq. Calculate the molar mass first. At 6.5. By now, you should have memorized the molar mass of HCl, and you have memorized the unit to be gram per mole. So let's use the formula. Mole per dmq in gram per dmq equals to over molar mass. So 2.8 is already in gram per dmq. That's why I'm using it. Divided by 36.5. So finally, I have what? 0.0767 as the mole per dmq of my acid. Quickly, second, let's look at concentration of B in mole per dmq. Let's use this formula with analysis of your parameters quickly. So what do we have? If you substitute the value correctly and make C is out of the formula, you're going to have 0.117 mole per dmq. This time around of what? Of E. Of what? Of E. So let's calculate percentage purity. Percentage purity by formula equals to pure over impure times 1 times 100. But let's calculate our molar mass first, because we have to convert what we have for E, which is the base, from mole per dmq. We have to convert it to what? To gram per dmq. That's why we are using this formula cross multiply to gram per dmq, which is 4.68 gram per dmq. So our percentage purity now, pure. This is our pure now. This 4.68 is my pure, while the value given 7.3 is my impure. It's stated in the question, impure of NaOH. So multiply by 100. So you have your final answer was 64.12%. 64.12%. Another way you can approach this is if you don't want to convert the mole per dmq of the pure to gram per dmq to be on the same unit with the impure, then you convert the impure from gram per dmq to mole per dmq so that it can be on the same unit. But it's okay. This one is very, very easy for me, so I just follow this. I also teach my students on how to undo that. You can see that. Let's quickly go to the next question. Question number 5. D is a solution containing 5.0 gram of HCl in 500 cm3 of solution. E is a solution of any of unknown concentration. This one question is not known. You can see the twist in all the question I'm bringing your way. They are solid past questions for WAEC, and they are highly predicted. All right. So let's look at this is our table. By now, you should know how the table look like, so you can get your 3 10 marks. So let's look at the question. Number 1, concentration of D in mole per dmq. Yes, concentration of E in mole per dmq. Concentration of E in gram per dmq, and mass of NaOH formed if 250 of NaOH were neutralized. If 250 of NaOH were, of course, 250 of NaOH were, of course, sodium hydroxide was neutralized with what? HCl. Okay, from our balanced chemical equation. So let's calculate the concentration of D mole per dmq first by converting 5.0 in 500, of course, to 1000 dmq, which is the gram per dmq. So it just gives us what? 10 gram per dmq. So molar mass of HCl is at 5.5 gram per mole. Then concentration of mole per dmq, you substitute the value, you have 0.274 mole per dmq. That's of D. That's of D. All right. Quickly now, let's look at concentration of E in mole per dmq. Let's follow all our parameters. Then you substitute our parameters correctly. Then you make C use of the formula. You can see it there. And our finals will be 0.417 mole per dmq. Are you following? Now, the next thing, calculation of E in gram per dmq. Then our molar mass first. Our molar mass is gram per mole. That's 40 gram per mole. So use our formula. That will be 0.417 cross multiply by 40. That give us 16 points. That will be 16.8. That will be 16.68 gram per mole. All right, to calculate the mass of NaCl formed if 250 of NaOH were neutralized by the acid. Of course, look at the balanced chemical equation, HCl plus NaOH to produce NaCl plus H2O. Okay, this is a balanced chemical equation. All right, now we are asked to calculate the mass of sodium chloride, okay, when you have 250 of this, okay, when neutralized. So we can use from the balanced chemical equation, you can use this method. First of all, this is 1 mole and this is 58.5 gram. When you check it out, okay, 1 mole. But this sodium hydroxide is in mole per dmq. So we have to convert sodium hydroxide to mole by using number of mole equals to CV over 1000. Remember this formula? So this mole per dmq 0.417 multiplied by 250, giving us sodium hydroxide, divided by 1000, give you we give us 0.104 mole of HCl. Now, from the balanced chemical equation, you can see that 1 mole, okay, 1 mole of NaOH produces 58.5 gram of what? Of NaCl. So what we 0.104 moles of NaOH produces when you do your cross multiplication, of course, you are going to have 6.08 gram of sodium hydroxide. I hope you enjoy this class and I hope you enjoyed this video. If you did, kindly do it to subscribe to my channel. Always do that. Stay tuned for more videos and comment A1 is my portion in my chemistry. Thank you very much for watching my video. God bless you as you watch more of our video. For me, to you, bye for now. Signing out. Thank you for subscribing.